Now let's get into harmonics and look at the basics of harmonics. What is a harmonic? Well, the definition is it's an overtone accompanying a fundamental tone at a fixed interval. And all that basically means is the fundamental tone is the pitch that you're singing or playing. So when I play this note here on the piano, that's the fundamental tone. That's the tone, the pitch that you see on the sheet music. But accompanying this fundamental tone are overtones. They are tones that exist above the fundamental. So really what you're hearing is as I play this note's in it, this note's in it, this note's in it. All of those notes are contained within this one. And those upper harmonics, those overtones, give the fundamental pitch its color. And that's very important for us as singers because the human voice is very rich in overtone content. The overtones in the human voice are quite loud. They're often louder than the actual pitch that you're singing. That's why the voice has so much energy and can sound so ringy and bell-like. That's where it's very different from other instruments. In the piano, the fundamental's the loudest, and then those overtones are there, but they're not quite as loud. Now, harmonics are actually a subset of overtones. So when we're talking about these pitches that exist above, these overtones, they're more correctly called harmonics. Harmonics are a subset of overtones. Overtones can be an irregular pattern. And what I mean by that, if we hit a gong, there are overtones in there, but they happen not at precise intervals. So we hear that a bit more as noise as opposed to pure pitch. And this is just to be very exact, but you'll want to call them harmonics rather than overtones. Now, as a subset of overtones, harmonics have a regular pattern. They occur in equal distance to each other. I'll show you on Voce Vista. Here's a note being sung. Now, this first peak here is the fundamental, and we hear that as the pitch being sung. And then you subsequently have these harmonics that follow. So the fundamental is also called the first harmonic, then you have the second, third, fourth, fifth, and so on. And you'll notice each one of these is the exact same distance apart. Now, if more of the energy is concentrated in these lower harmonics, the sound will tend to be a little darker. If it's concentrated more in these higher harmonics, the sound will be a little bit brighter. And depending on where you're singing in your voice, you're going to want certain harmonics boosted over others. And we'll get into that later on. Now in this section, we're going to get into a little bit of math. I don't want you to worry if you don't get this right away. As long as you understand the basic concepts, you've come a long ways. This section may take a bit of repeated viewing. That's fine. You'll ultimately get it. It's not crazy hard math. It's not rocket science, as they say. Pitches vibrate at cycles per second or hertz. In other words, if I play this A, that's an A440. And what that 440 represents is how many times per second that sound wave is vibrating. Now, when we talk about this 440, that's the speed of the fundamental. That first peak that you saw in Voce Vista, the one furthest to the left, that's vibrating at 440 cycles per second. The subsequent harmonics above it vibrate more quickly. Now, the pattern that they occur in is that the harmonics are multiples of the fundamental. So I'm going to make this a little bit easier. I'm going to start this on a lower A. This A is A110, which means it vibrates at 110 cycles per second. So then we get a harmonic at 110 every 110 cycles. So we're going to have a harmonic at 110. That's the first harmonic or the fundamental. And then we will have subsequent harmonics at 220, 330, 440, 550, 660. So every harmonic is spaced 110 cycles apart. Just for reference, the harmonics are numbered as such, H1, H2, H3. If you're reading something and they're talking about harmonics, that's usually how they will be notated, as H1 or H2. Just know that H1 is the fundamental, is the actual pitch. So on this A110, H1 is the A, and then we have H2, H3, H4, etc. Again, the fundamental will be called H1. And here is the overtone stack, or the harmonic stack. So this low C here, you will notice we have a harmonic. The second harmonic occurs an octave above. This one's the first. Then the third occurs a perfect fifth above that. And then we jump a perfect fourth to middle C. And then it's a major third to the E, and then a minor third to the G. And then we get the B flat. And then we step up a whole step to the C. It's actually creating a dominant 7 chord. And you will see as the harmonics continue to go higher, they get closer together on the staff. And there's a reason for that. Even though they're still the same distance apart, they don't line up in terms of pitch, because octaves behave a little differently than harmonics. Octaves are doubling of the frequency. So if you have an A110, then the octave above is vibrating at 220. But if we want to get the next octave, we have to double that 220 to 440. And then if we got an octave above that, that 440 is multiplied or doubled and becomes 880. So you can see the octaves have really big jumps. That's why the first to the second harmonic is the jump of the octave. It goes from the A110 to the 220. But then it doesn't jump again, because all of a sudden the octave jumps to 440. Well, the harmonic is only going to jump up to 330. So it ends up landing on the fifth. The greater or the higher the pitch of the fundamental, the greater the distance between the harmonics. This is the key point that I want you to understand. An A440, remember we talked about the 110, and then we get a harmonic at 220 and 330. Well, the A440 up there, well, now the harmonics are multiples of the fundamental. So now each harmonic is 440 hertz or cycles per second apart. So the first harmonic is at 440, the second's at 880, then 1320, 1760, etc. Now, if we take this up another octave, all of a sudden those harmonics, because this fundamental is now at 880 hertz, because we have doubled 440 to 880 to get the next octave, every harmonic is now 880 cycles per second apart. So we have the first harmonic at 880, the second is at 1760, the third is at 2640, 2,640 cycles per second. It's quite a distance. I'm just going to show you. So here's a low pitch sung into voce vista, and you can see the distance between the harmonics. Even though the distance is the same between all of them, they're quite close. Just going a little higher, suddenly the space begins to widen between them. The higher you go, the greater the space between these harmonics. And this is important because where we derive power from the voice is by these power boosts. And what we're boosting are harmonics. We need to align our resonators with certain harmonics. And there are harmonics we want to boost in the lower voice. There's harmonics we want to boost in the higher voice. They'll change. That's why we have bridges, and we'll get into that. But as you go higher, the distance is greater between the harmonics. It's easier to miss them. That's why very often when you go for a high note, suddenly it feels unstable, it falls apart, it gets weak, or your chords jam up because you can feel it's not going to make it. And what's happening is you're actually missing the harmonic that you need. You're falling in between them. Harmonics can be controlled by the singer. And by control, what I'm talking about is aligning our resonators to pinpoint the exact harmonics that we want to boost. And we can boost harmonics not just for vocal balance, but you can also tweak the harmonics for vocal color if you want a slightly darker sound or a brighter, more robust sound. And as you master this, you become a greater and greater master of your voice. All the colors start to become available to you for expression, and that's ultimately what we want. We want to be able to communicate and express through our instrument. It's very much like the idea of an EQ. Now, if we're playing a CD and the signal is traveling through the EQ and then to the speakers, the information from the CD on a particular song is always the same. It's always sending the same information to the EQ. However, by moving different parts of the EQ up or down, we really change the experience of the sound. If we take this EQ and we turn down all these high ones and only boost the low ones, it's going to sound very dull and muddled, woofy. If we lower all the low ones and boost these high frequencies, it's going to sound bright and shrill. It's not going to be balanced. Think of each one of these bands as a harmonic. You have the lower parts of the sound spectrum and you have the higher parts of the sound spectrum. And we're able to, like an engineer or a more advanced stereo system, we're able to pinpoint parts of the sound spectrum and either lower or raise depending on the result that we want. Now, how do we change what's being boosted? Well, the answer is through formants, and that's what we're going to cover on part 3 of this series. So I'll see you over at the next video.